Okay, once you set up the sample on the microscope, then you open the XAMPP 3.5 software. Here is how you're gonna look into it. So we have 5 different tabs for different applications. Most used are the first 3. Locate tab is for you to locate where the sample is. And acquisition tab is for you to do taking images and adjusting, like for example, the pixel size, laser time, and laser intensities. And the processing is the post image processing after you take the images. Analysis is for some analysis use. So here, once we set up our calibration chip on the microscope, we can decide which lens we want to use. Right now, I'm using the 20x. So 2.5, 10, and 20x are the common microscope lens we can use. And for the 63 and 100x, these 2 are oil lens that we need to apply oil to it before using. So once you set up the calibration chip, we want first to find out where the exact location we want to look into it. So what we are going to do is take the wide field of the image. So how we're going to do that here? This, we can look at here, the microscope control panel over here. This is telling you which light path you are using. For example, we want to use the transmission wide field. We need to turn on the transmission light here. And the intensity, usually you just need somewhere around like lower than 15%. That should be good enough for commonly used. And you can see the light of the path is showing you how the light is going through the whole system. It's going through the bright field and then going to the stage where the sample is. And at the bottom is the lens we're using. You can change the lens you want to use here, but always be aware about if you're using the oil lens or not. And then it's going through here. You can decide whether you want this to go through the objective that you can observe the image by your eyes, or you want to use the camera to see it. Like you can see the path is changing here. And on the right hand here, these are for the fluorescence use. So we're gonna skip it for now. So once you check up all the path for the white field, then we hit live tab here. And you can see this is the image of our calibration chip. And you can notice that it's kind of overexposed because the light intensity we use is 12% here. So you can also notice that from here, you will notice that it's overexpressed. We can use the range indicator. The red spot here is telling you that your image is too light. So you need to lower down the intensity. So let's maybe go down to 9%. You'll notice that the red spot is no longer here, which is telling you that all the pixel intensity is within the analyzable range. Okay. And now you can adjust the focus by the focus switch that you on the machine, you just rotate it, or you can adjust the focus here. See the focus panel. This is telling you the Z stack where you are right now. And the step size, you can change it to adjust the focus step. So for example, we want to adjust the step to 0.5 micron. And then by applying up or down here, we can adjust our focus. It's not that obvious. Let me do 1 micron. Will be more obvious. You can see we're out of focus, and then we're in focus again. So once you got the focus you want, then you just stop the live image and then take a snapshot. Then now you get the image of the location you're looking at. And if the as we hit the live, and we know that this is the we are setting the focus right now, but this is not the place we want to look at. You can use the joystick to move the stage, or you can just double click on the image like here. I double click on the left, so it's moving to the left, or I double click to the bottom, then it's moved to the bottom. And once you move, you will like to refocus it again so that you can get the best resolution at the location you're looking at. And that is basically how you make your microscope in position with the sample you want to see. Okay, so this is the wide field. And then after the wide field, for example, if we have this sample stand with a certain kind of fluorescence and you want to see it, now how are we going to do that? So we can just turn off the transmission light for the wide field. And then now here, go to the laser for the fluorescence here. We have 4 LEDs for the location use laser. So for example, if we want to see, if we have the green dye, usually the emission range is around 480 to 50 or 530, then we'll use this 475 as the excitation. Here we can adjust the intensity, usually around 10 to 20% of the intensity is good enough for you to do the observation. So you can notice that the light path is going through here, but here the shutter is closed. So you just click it on to make it open and go through. You can always debug why you cannot see the image or not by checking this light path. And here is the reflector changer. So because we are using the green channel, we can either use this filter reflector or use this one to check the fluorescence. So here I'm going to use this. We are only look at the green light. So it's going through this way and then go to the camera. And then once we check the light, then we do live scan. And you need to here adjust the threshold. That is the way how you can see the fluorescence. So although you are seeing black and white here, it's actually the fluorescence image. And for the color, we will later do acquisition to show it. So right now I can just take a picture of it. And this one is the green fluorescence. And we can just use here to change to the color we want to see. And then if we have red dye of this material or orange dye, let me do orange dye first. Then we need to switch the range and then do live scanning again. Now see, this is the area of the sample that has the orange dye. So we can stop it, take a snapshot. See, this is the intensity. So you can see the intensity here. And you can change the color to wherever you want, like this. And these are the same location we're looking at. And you can notice that the intensity is relatively strong compared to the background. Okay, so we are done. This is how you do the localization for the sample.